Welcome to the Explainer. So, today we're going to tackle something that literally every student, professional, or just, lifelong learner struggles with. And that is moving from passive reading to true, absolutely unshakable mastery of a subject. I mean, we've all spent hours poring over texts, right? But how often does that actually translate into usable knowledge in your brain? Well, let's dive right into this because we're going to explore a really simple, practically foolproof method that completely transforms how your brain processes and retains complex stuff. It's an elegant system, and it basically guarantees you actually know what you think you know.
Seriously, have you ever been there? You've read your notes, you've gone to town highlighting all the important parts in neon yellow, you're sitting at your desk feeling incredibly confident, and then bam, someone asks you a basic question about it, or you sit down for an exam, and your mind just completely blanks. No way around it, it's an incredibly universal and incredibly frustrating pain point. We have all experienced this sudden total vaporizing of knowledge. But listen, what you're experiencing in that moment, it's not a failure of your intelligence. Not at all. It's a failure of method. You've just fallen victim to what cognitive scientists call the illusion of competence.
So to break that illusion, we have to understand the massive, and I mean fundamental difference between passive recognition and active understanding. See, when you reread your notes, your brain looks at the words and essentially goes, yep, I've seen this before, makes total sense. But that feeling of familiarity, it tricks you. You end up confusing recognition, which is totally passive, with understanding, which is highly active. True understanding actually means you can look at a concept and confidently say, I can explain exactly why. Just reading and highlighting, that just creates this deceptive little comfort zone. We need a way to force our brains to retrieve, organize, explain, and connect that knowledge instead.
And that brings us to the core philosophy of our explainer today, perfectly captured in this idea. If you cannot explain something simply, you probably do not understand it well enough. This right here is the guiding principle behind the Feynman Technique, named after the absolutely legendary physicist Richard Feynman. Now, Feynman wasn't just a Nobel laureate. He was famously known around the world as the Great Explainer. He had this incredible, super rare ability to take mind-bendingly difficult scientific ideas and translate them into clear, intuitive, everyday language. Basically, he knew that complexity is very often just a mask for a lack of profound understanding.
So how do we replicate his genius? Well, we use his method. The Feynman Technique is a highly structured, four-step cycle that acts as your ultimate roadmap to mastering complex information. Step 1, choose a concept. Step 2, teach it. Step 3, find gaps in your knowledge. And finally, Step 4, simplify and connect. By rigorously looping through this cycle, you basically strip away that illusion of competence we talked about and build a rock-solid foundation of actual understanding. Let's break down each of these steps and see exactly how you can start applying them to your own learning right away. All right, let's start with Step 1. Choosing a concept. You've got to take that massive, tangled web of a subject and zoom way in on one single part. Don't go picking broad subjects like physics or advanced statistics. You need to pick specific, isolated concepts. Think along the lines of Newton's second law, orbital velocity, Kalman filtering. You really need laser focus on a single gear in the machine to get started. Because if your scope is too broad, the whole technique just falls apart, simply because you won't be able to effectively isolate your blind spots. Okay, once you have your specific concept, Step 2 is to translate it. Now, close your textbook, hide your notes. Think of the robotic, super academic textbook definition of Newton's second law. It probably sounds something like acceleration is proportional to the net force and inversely proportional to mass. Right, okay, technically true, but incredibly dry. Now, contrast that with how you would explain it in plain English to, say, a first-year student. A force changes how an object moves. If I push harder, it accelerates more. If the object is heavier, the same push produces less acceleration. See the difference? The goal here is absolutely not to sound smart or academic. The goal is to make the idea undeniably understandable. Now, as you are enthusiastically explaining your concept in plain English out loud, you will inevitably hit a wall. You're going to reach a point where you stumble, look at the gap in your knowledge, and think, actually, wait, why does that happen? I mean, I know the equation, but I don't really know what this specific term means. Welcome to Step 3. This is the magic moment. Seriously, when you freeze up, do not view it as a failure. This moment of friction is actually a highly useful treasure map. It's literally revealing your exact specific knowledge gaps, the very places where that sneaky illusion of competence was hiding all along. So what exactly do you do when you hit that wall? Well, you go back to your resources. Return to your lecture notes, crack open that textbook, look at worked examples, whatever materials you have on hand, and you study that specific gap.
Notice I didn't say reread the whole chapter. You are on a targeted search and rescue mission for that one single missing piece of logic. You patch that specific hole in your understanding. And then, and honestly this is vital, you close the materials again and you try explaining it from the top all over again. You just loop through this process until you can get through the entire explanation without a single stutter.
Let's move on to step 4 and see how all this builds into true mastery. Simplify and connect. Once you actually understand the core mechanics without relying on your notes, it is time to refine it. Strip away any lingering jargon. Introduce everyday examples, analogies, or draw diagrams. Let's take the concept of momentum. Instead of just blindly memorizing the formula, P equals mv, you describe what it actually means out in the real world. Momentum describes how difficult it is to stop a moving object. So if you compare a really heavy truck and a bicycle traveling at the exact same speed, they obviously don't have the same momentum, right? Because the truck has so much more mass. By attaching the raw math to a vivid, visual analogy like a truck and a bike, you completely cement it in your brain.
But hey, step 4 doesn't just stop at a good analogy. To make this knowledge permanently stick, you need to connect this simplified concept to broader applications or things you already know. Ask yourself, why does this actually matter? If we take our momentum example, why does it matter in engineering? Well, it turns out it's the foundational concept for vehicle safety, understanding collisions, spacecraft docking, and even rocket propulsion. When you connect a raw concept to real-world tangible applications, it goes from being just some abstract formula to a highly useful tool in your mental toolbox.
So, here is the absolutely crucial point. The objective of the Feynman technique is not to pretend that complex engineering, physics, or statistics is somehow easy. Let's be real, some concepts are genuinely incredibly difficult. The true objective here is to strip away your ego and discover exactly where your understanding stops. And the best part? You don't even need a real person to teach it to. You can explain it to an empty room, you can write it out on a blank sheet of paper, or just record a voice memo on your phone. The physical act of outputting the information highlights your limits. And identifying those limits, that is exactly where your next round of learning should begin.
As we wrap up this explainer, I really want to leave you with a completely new standard for how you evaluate your own knowledge. We need to throw away the old metric. Seriously, stop asking yourself, have I studied this? Because, as we now know, just reading creates a totally false sense of familiarity. Instead, I want you to start asking yourself this one powerful question. Could I teach this without looking at my notes? If the answer is no, well, you have more work to do. But the good news is, now you have the exact tool you need to do that work effectively. So start explaining, start finding those gaps, and watch your understanding completely transform.